Hello everyone. I wanted to show you guys how I approached problem 23.8. It seemed like there may have only been one other post about it, so not sure if maybe a lot of people are confused about it or just haven't posted their solutions for it yet. I don't know, but if it is the case that people aren't sure, hopefully this helps. Um, so we're basically asked to derive equations 33 and 34 from chapter 23. So starting out with equation 33, we're basically trying to prove the definition for the elastic modulus. So I started out with equation 32, um, uh, made it simple, and just set indices on everything to sigma 1, 1. Basically, making the assumption that all the other stress components except for sigma 1, 1 are equal to 0. So it just simplifies things quite a bit for us in this case. So I substitute in those indices on sigma and epsilon in equation 32. Then I can use the relationship also given in the textbook, which is just the definition of elastic modulus, is stress over strain. So I can then sub that in for sigma 1, 1. So I do that. All I do in these three steps is just simplify that last term with the lambdas and mu's in it. Factor out an elastic modulus and epsilon 1, 1. I can then divide off the epsilon from both sides, and then rearrange to have the elastic modulus on the left-hand side of the equation. And at this point, anyway, we are just doing algebra basically on the right-hand side. So we multiply the 1 by 3 lambda plus 2 mu over 3 lambda plus 2 mu. We could then squash the denominator into one expression, subtract off that single lambda, factor out a 2, and then that 2 cancels with the numerator, and then we are left with the equation that we were trying to derive here. Similar process for deriving Poisson's ratio. So again, we're starting out with equation 32. In this case, the book gives us this relationship for strain tensors and Poisson's ratio. Actually, it's negative. So I took that as a hint for how to solve this portion of the homework problem. So basically, I just set the left-hand side indices to 2, 2, and the right-hand side to, or the first epsilon and first sigma to indices 2, 2, and the last sigma to 1, 1. So I can basically use that to get rid of sigma 2, 2, since we already made the assumption that all other stress components aside from sigma 1, 1 are equal to 0. We can get rid of that sigma 2, 2, which simplifies things quite a bit for us. So anyway, we make that substitution here. We can then divide off that epsilon just as we did for the elastic modulus derivation. And then in this step, what we're going to do is sub in that equation for the elastic modulus, for E anyway. And things are pretty obvious from that point on, that 3 lambda plus 2 mu cancels out on the right-hand side. We can then divide in this step by that negative 2 mu, and then we get the expression for Poisson's ratio that we wanted.